This is exercise 8F on geometric sequences on page 379 of your textbook. Quick do now question. This is just based off the content we learned in exercise 8E. We're presented with a geometric sequence. Off the bat, our sequence is going down. So should our common ratio be greater or less than 1? Less than 1. Theoretically, it should be less than 1, right? Awesome. So to find the next term, I know that I'm dividing by 2 each time. So my next term is going to be divided by 2, which gives me an answer of 4. That's part A done. Part B says show the position and values of the first 4 terms. I'm going to go ahead and write my table over here. I have N and Tn over here. 1, 2, 3, and 4. I'm going to write my values in. So I've got 32, 16, 8, and 4. And the next part tells me to use the table to plot the graph. Before I plot the graph, should the graph be a straight line or a curve? Curve, good. It should be going down as a curve as well. So let's draw our graph over here. 0, 1, 2, 3, and 4. I know my first value, my largest value. I'm hearing a lot of chatter up the back. Thank you. My largest value is 32. My smallest value is 40. So I'm going to go ahead and label this as, 4, sorry. Label this value as 32, 16, 8, and 4 over here. Putting them down, I got 32, 16, 8, and 4. Are my points in a straight line? No, good. So I've done it right. It should theoretically, and you're not supposed to connect the dots, but just for demonstration, I will. It should theoretically look something like that in that direction. Awesome. Let's get into the content for today's exercise. We're looking for the nth term in a geometric sequence. Just like we did with the arithmetic sequence, we have a formula. Before we get there, I'm going to show you where it comes from. Okay? So we've got this example here, where we have the values of 2, 6, 18, 54. As you can tell, they're being multiplied by 3. Our ratio, or common ratio, sorry, is 3. The calculation as goes here. Okay? T1 is 2. That's pretty straightforward. A equals to 2. I know that the next term is just the last term times by 3. Pretty straightforward. I want you to focus on the red text, by the way. I know that T3 is going to be T2 times 3, or T1 times by 3 times by 3. I know that if I continue, there we go, T4 equals 2, and you could say T3 times by 3, or we could say T1 times by 3 times by 3 times by 3. Okay? We prefer the multiplication way because it gives us a general form of formula. You can see in the red text it does specify to calculate the nth term in this particular sequence, write down the first term and multiply it by the common ratio to the power of n minus 1. So this formula right here, can I get you guys to write that down? Thank you. And I definitely recommend you guys write down this right here as well, r equals to the common ratio. You guys would have had a equals to t1 and n is a position term already, so I recommend you guys write down the formula and write down r equals to common ratio. Can you guys see that up the back, Russell? Yep. Awesome. Okay, leave that up there so you guys can read it. Very easy example. We're going to jump right into it. In this example, we've got T15. Thank you. We've got T15, the 15th term, in the geometric sequence, which goes 3, 6, 12, 24. So, what are the 3 things I need to identify before I can use the formula? R. A, the first term. Good. What's the last one? N. Thank you very much. Let's identify them. Let's go A, our first term, which is 3. I know that N is going to be 15, because that's my 15th term I'm looking for. And finally, R, which is the, what's the value of R? How do I find R? Is it times 2 or just 2? Just 2. Good, thank you very much. How'd you know it's 2? Because it's doubled. Good, it's doubled. If we were going to show it mathematically, I would write 6 over 3, or you could write 24 over 12, whatever it is, which simplifies to 2 anyway. Good. So to find the 15th term, I'm going to use the formula I circled above. So I'm going to write T15, which equals to A, so that's 3, times by R, which is going to be 2, to the power of 15 minus 1. Okay? When you put that in your calculator, and once again, those of you watching the recording won't be able to see this. When you put this in your calculator, I'm just going to clear the screen for now. It's going to look like 3 times 2, and then the power of button is this arrow right next to the divide symbol. So you're going to hit that button there. That just means power of. And you're going to write bracket 15 minus 1. The reason why you're going to write bracket 15 minus 1 is if you get rid of the brackets, I'm going to actually copy and paste and write the same answer here, but I'm going to get rid of the brackets. It gives you a different answer. Does anyone guess why it gives you a different answer? Casper?
Because it does it in a different order.
What do you mean by different order?
It executes the operations in a different order.
Yeah, it could, yes, but there's a very specific reason why. Yes?
Does it do 2 to the power of 15 and then minus all things?
Good. It's considering that right here as 2 to the power of 15. And at the end, it's going to minus 1. Instead of, in this situation, what it actually is meant to be 2 to the power of 14. Yeah? So please make sure that you have brackets around the 15 minus 1. Okay? The calculator is smart, it's not that smart. So our answer is 49152. Very large number. Okay? I'm going to leave that up on the screen so you guys can see. And I'm going to go through the next part here. Do you guys want me to scroll back up to here? Is that better? Yeah? Lovely. Okay. The next component is an example of percentage change. Now, you guys have done percentages in the past. Some of you guys would have hated them before. But we're going to try and keep this as simple as possible. Let's say that you have some money saved up. You have $100. And each day, you spend 10% of that money. Now, of course, you're not going to spend $10 each day, right? Because let's say if you had $100 first day, you spend 10%, you have $90 the next day. Then what's 10% of 90? Well, it's $9. You're going to spend $9. You're going to spend less and less and less and less, right? So it's not exactly just 10% of the original number. So how do we model that using a sequence? I'm going to very quickly just show you the left-hand side here. I want you to focus on this part here. Okay? So I've got t equals to 100. That's our first term. That's how much money I have the first day. And what we could write is 100 minus 10% of 100, which we know 10% of 100 is 10. So it's 100 minus 10, which is the same as 90. And we can do the same thing, and we can say 90 for the next term, minus 10% of 90, which we know is $9. So 90 minus 9 gives 81. But it gets a bit repetitive, doesn't it? Right? Especially because you have to do it manually each time. It's fun. 10% of 100, 90, 10% of 81, 10% of... You get that idea. Instead, what we can do is instead of taking away 10%, we can just find 90% of that value. 90% of the value. So we can say, for example, 100 times by 9.9, sorry, which we know is the same as 90%, by the way. And then do the same thing for 81, 72.9, and so on. Okay? So instead of finding 10% and minusing that away, we find 90% of the original value. Can I get you guys to copy this down? Thank you. For a p percentage reduction, and by the way, reminder, you are more than welcome to write shorthand. You don't have to write each and every single term. For a p percentage reduction, when making each new term, use r equals to 1 minus p over 100. So that's this section here. And then, of course, for percentage increase, 1 plus p over 100. As you guys are aware, money doesn't always go down. You could model for example, interest in a bank account. Same idea applies if it's the same percentage. What's the difference between the two formulas? Good, plus and a minus, it makes sense, right? If it's decreasing, we minus. If it's increasing, we add. It's actually just a different form of what we already know with the geometric sequences. Okay, I'm going to move down a little bit. I'm going to keep that on the screen so you guys can see, but I'm going to put that into practice over here. So, the question says, state correctly 2 decimal places the first 4 terms in each of these geometric sequences for the changes given. So let's say you start with 200, and each new term is 4% less than the previous term. If I was to put that into context of the analogy I was given earlier, let's say you start off with $200, and each day you spend 4%. That's all it's asking. So, of course, we have to be able to find the value of R. If I'm losing 4%, I'm going to go ahead and write that in. So my R value, let's focus on A for now. I know R equals to, I'm going to follow the formula. And which one do I use, the top one or the bottom one? Top one, good, because it's going less. So 1 minus. Now instead of writing P, I know P% is going to be 4. So it's 4 over 100, which gives me 96 over 100. You can just chuck this in the calculator, by the way, which gives us 0.96. So before, when we're trying to take away 10%, we multiply by 0.90. Now I'm taking away 4%, I'm going to multiply by 0.96. Okay, awesome. Continue on from there. I've got my R value. It's telling me to find the first 4 terms. I know the first term is 200. The second term, once again, I'm going to grab my calculator out. I'm going to hit 200. I'm going to multiply by 0.96. Hit enter. My next term is 192. Hit enter again. My next term is, and do I want to write it in the fraction form? No, because I need it to be in good decimals, 2 correct decimal places. So I select this answer here, and then I just press the top button there, 184.32. And then finally, oh, that's a very gross answer, 176.95, rounded to 2 decimal places, remember. For option B, my answer is going to be increasing, isn't it? So I need to use the second formula. So with the second formula, I know I start off with 500, but it's going to be 12% more than the previous term. Same formula, except I'm going to add instead. So R equals to 1 plus 12 over 100, which if you put that in the calculated decimal form is 1.12. It is now greater than 1, so each term is going to be greater than it was before. Okay? So in that situation, our first term is 500. So I'm going to put 500 equals into the calculator. I'm going to multiply by 1.12. By the way, that asterisk there is just times, by the way. And I get 560. Next term, I hit enter again. It's going to be 627.2. And finally, it's going to be 702.1. Oops, sorry, not 0.1. It's going to be 0.46. So that's how we calculate it. The 2 things you need to keep note for this exercise is first off, what the actual formula is. And of course, after that, how do we find the R value in a percentage increase and decrease? Any questions beyond that? Great work.